Thank you. It's nice to be down here to share what our contribution was to the build of the Team New Zealand boat, and also what we do as our sort of other business and where we're hoping to head. So today in my 10 minutes I'm going to go through a little introduction to Composites. Seeing this is sort of a tech conference, we might not have the sort of basics understood, so I'll go through that. Southern Spars, who we are, what we do, what our core business is. The ETNZ build, a few photos there, and sort of how we went about it, and then sort of a bit of an outlook of the future of the New Zealand composites industry. So if we go back to Composites 101, what is a composite? So generally you're combining a fibre which has very good tensile properties into a matrix, which is usually some sort of resin, but not necessarily, which has good shear properties, into a composite, which has the best of both worlds, really. So composites been around for a long time. Wood is a composite of cellulose and lignin. Bone is a composite of collagen and something made of calcium. And as things have progressed, things got a little bit more developed. So straw and clay to make an adobe brick is an early composite. Reinforced concrete is another example. And then as we develop the technology, we get into carbon fibres in epoxy resin, which is sort of where Southern Spars works in that area. And there's also a sort of a new area of carbon and thermoplastic. So thermoplastic, like what everyone would call a plastic, you can melt it and infinitely reuse it. So Southern Spars, we work in the carbon epoxy thermoset world. So the beauty of composites are that they're tailorable. You can put the fibre where you need it and not where you don't. So that tailorability that composites are so well known for also means that they're also quite difficult to manufacture, because when you're manufacturing the part, you're also manufacturing the material. So generally, the manufacturing processes aim to put a resin and a fibre together to form a composite. And so there's a few goals. You want enough resin to bind the fibres together. Otherwise, you've just got like yarn, basically. It's a rope. It's got no compressive strength. But you don't want more than you need, otherwise it's too heavy. So that's a tricky game. You want enough, but not too much. And no voids, which is also very tricky. So generally, there's a few sort of thermoset composite manufacturing processes. If we go to wet lap on the left, which is what we call bucket and chuck it, is throw resin and fibre into a mould and she'll be right. And so generally you might end up with 50% resin, 50% fibre. Then sort of another technology step is resin infusion, where you draw the dry fibre, you have the dry fibre under vacuum, and then you draw resin through, and you don't put as much resin in. And so that might end about 40% resin. And then where Southern Spars operates is what we call pre-preg, which is pre-impregnated with resin. So it comes on a roll, it's quite sticky, and it already contains a certain amount of resin which we prescribe. So you end up with about 30% resin, so it's a lot lighter. So that's where Southern Spars operates. So if we look at Southern Spars Global, how am I going for time, by the way?
4 minutes.
Sweet. So we started in New Zealand by a group of Kiwi sailors, still headquartered here. In New Zealand, about 180 employees, around the world about 600. So if you look at some recent projects, Trip 85 metre ketch, a Quiho is now it's called, 2 94 metre long masts, too long to be shipped, too long to drive on the New Zealand road, so we shipped them to Tauranga and a bit of glue and stuck it together, and then went on the ship and then to Europe. So it's a fair bit of engineering that goes into that glue, but she'll be right. And then another recent project, which was a really cool one I was involved in, was track cycling wheels for the New Zealand Olympic team. Might scare some people, but 70 days before the Rio Olympics, we took our first prototype to the velodrome. And then we delivered 32 wheels for Rio, and they got a silver medal and current world champions on those wheels, and current holder of the world record fastest first lap at sea level. Then if we go into the ETNZ build, so Southern Spars built the wings, 2 wings for Team New Zealand, and then we were asked to build the hulls, which was the first boat we've ever built. Southern Spars has only ever built 1 boat, that's it. And we also built 1 set of dagger boards, which Cam from Jackson's was involved in the other set, so he'll talk about that. So I'll talk about the wings and the hulls. So generally, a wing is made up of multiple elements, so you can pull it apart. So you can adjust the twist and adjust the camber. And so generally they're made as a sort of a leading edge section, a pre-preg, which sort of the shell looks on the left, and the middle one is sort of internal structure bulkheads. This is bottom where it attaches on like a tow ball thing to the boat. And then there's these fine ribs which give it the shape, and then there's basically a big sort of cling film thing that goes over the top to give it the shape. And so when they crash, like these things just destroyed. And then if we look at the hulls, so we have 2 female moulds. We lay them up in 2 halves, a deck and a hull. So this is the deck mould on the right. You can see the rebates for the cockpit cutouts where the guys stood, so that's upside down at the moment. You cook that, pop it out of the mould, looks something like that, so that you can see those holes where the guys stand. Then you have 2 halves, glue it together, bit of glue, she'll be right. And then there's also a lot of internal structure which you don't see on TV. So this is looking aft. That's the transom there, and that's where the sort of rudder area. And then you make 2 of them, and you join the beams on. Away we go. So one thing that's interesting, we built the boat, but we didn't know there was going to be cyclists on it. They kept that really secret, which was incredible. Like, I don't think you guys didn't know, right? No one knew. It was a very hush-hush, and so there was no things that were called reinforcement for bikes here or anything like that. It was all, we were just building a boat and they were going to have grinders on it as far as we knew. So you assemble it and you rally the troops and take a cool photo. I'm in there somewhere. Where's Wally? And then you pull it all apart again and get it painted, and like have to lift it across the workshop to the paint shop, and then it got flown to Bermuda. So if we look at the composites industry and where are we heading next, we can sort of, in tech speak, we can call what we do now as the New Zealand composites industry 1.0. So if you look way back, this was based on almost natural selection. Like, if you couldn't build a good boat, you didn't make it to New Zealand, right? So that's how the industry was founded. It's true, and if you didn't like sailing, you didn't sign up for a 6-month sailing trip or whatever, right? So we've got this skill base, both in manufacture and design, and you really shouldn't underestimate the skill of the craftsmen that we have working on these things. It's amazing. I'm a designer, you draw it up, and it just happens. And in lots of countries, there'd be so many like questions on the drawing, or what are we supposed to be doing here? But the guys we have in New Zealand, we're really lucky. Supply chain, that's a really important one, which is often overlooked with composites. You can't go down to Bunnings and get a sausage and a roll of carbon fibre. So we fly our carbon fibre in from Korea about once every 2 weeks on a chilled air freight shipment, and having that supply chain is really important. And we also have the equipment, autoclaves, pressurised ovens, tape layers, things like that, which make it efficient. So where to next for, if we call it New Zealand's composites industry 2.0, we want to look at high value complex parts. Rocket Lab is like the best example of this 2.0 industry. Efficient design customization. So we're not going to be doing mass production. People are going to be wanting custom parts. But how do you do that efficiently? How do you go from the customer's requirements to the structural engineering to the shop drawings to the part without involving someone at every stage having to transition file formats and silly things like that, which I'm sure there's lots of people who know more about that than me. So if you keep the humans on the innovation and then the mundane engineering tasks of the computer, that'd be great. Likewise for efficient manufacturing processes that you can customize. Reliable demand, not just toy factories. So yachts are a toy. It's nice to have things that aren't toys that keeps everyone busy when there's a bit of a downturn to try and even things out. New Zealand designed and built, which is an interesting one. So Southern Spars is unique in the super yacht industry in that we design the masts we build, whereas other super yacht builders, alloy yachts and things, they were competing against worldwide manufacturers who weren't just for the build, they were tending for the build, so they didn't have that value of the design that they were selling as well. And diverse industries, that's sort of what I mentioned before, rockets, helicopters, plane parts, whatever, that's what we're trying to get into to see where we can take things. And I think that's my time. Thank you.
Next, we have Milton Broomfield from Dynamic Composites. Do you have the slides?
Yep. Do I have them?
Yep.
Oh, yep.
Coming up. There you go.
Cool. Thank you. So I'll just start the clock. I have 5 minutes to tell you about 20 years, which is going to result in 15 seconds a year, so I'm going to miss some. Dynamic Composites, what do we do? What are we about? So we're about delivering excellence in composite design and creation. We're a small Christchurch-based team, which is that team. We have been bigger, and we have a really wide group of skills and experiences. So what do we do? Well, I guess what we like to do is make the hard easy. It's not easy for us, but it's what's hard for you guys. So we specialise in design, in prototyping, in developing, and also in small-scale production, so up to maybe 100 parts. We also have, what's very important to us, is a ISO 9001 quality management system, which is allowing us to work in the kind of work in the areas that we do. So we'll move on to the next one. Yeah, righto. So here's my opportunity to talk about what we've done in some of our projects. Starting at the top left, Sarah Ulmer, 2004. 2003, I get a phone call. Hi, it's Sarah Ulmer here. I'm looking for a bike for the Olympics next year. Can you help? Yep, sure. Still world record and still Olympic record holder. Martin Jetpack on the back of that work. Glenn rung up in 2004 and said, I'm working on a hovercraft. Could you come and have a look? And we were instrumental in that project up to about 3 years ago. A bit over 10 years ago, local entrepreneur Grant Ryan and a group invented a yike bike. They came to us at that time and it was aluminium, wood and plastic, and we introduced them to composites and we built the design with them and built the prototypes, which you see one there. Don't ask me about the bit that's camouflaged with the red because I can't tell you. I had to fill in some pictures, so we've got one there of a DTI doing some measurement, but that's really important for us. So some of the work we do, every single part's measured, and that's aviation standard. ISO, important to us. Team New Zealand we'll get to. We've done a lot of work also recently with some of our Paralympic athletes. So I've got to be honest and tell you I've lost count of how many world and Olympic champions that we've worked with over the years. But it's more than 20 and it's in between 5 and 10 sports. We love that work, we're really passionate about it. Doesn't pay the bills though. So we medal. So one of our guys is a drummer, our painter. So he wanted a drum, so we built him a carbon fibre drum what he enjoys playing. And then these guys down the bottom here, which is a Queenstown-based team that do work in the film industry and they're world class at what they do. And along the way, we have picked up an award or two. So that's who we are. Now, we were involved with these guys. When we got involved was for Boat 1, so we were involved with some components. Once we sort of worked our way in to that, then I was fortunate enough to spend time up there in the team and looking and asking questions and being annoying. And we got involved in a handful of special projects. So they were the things that were too hard or too time-consuming for the normal course of business. This is all right, I've got the 2-minute call, but I can't tell you any more about those anyway. What I can tell you about is is we ended up building the steering wheel. So, like Chris talked about, his prototypes turning up late for the Rio Olympics. These guys had left the country by the time we got round to building these wheels. So, we built 4 parts, 2 of them on the boat at any one time. Now, there's no way those parts could have won the America's Cup, but they sure as could have lost it. So, one thing that's different for us as the other groups here is we were involved in the design of these bits. So we're so proud of the fact that the team trusted us to tell us what they wanted and leave us to it. So essentially I had Pete Burling on the phone every other day asking me how it was going, a few Skype calls, and then they left the country as said, and then we got on with it and did it. So with that, we brought our manufacturing processes to our steering wheel that we've learnt from all the other stuff we've done and a lot of bike wheel technology as it happens. That's sort of the end of that, which is good because I've got 13 seconds. I hope we would have had time for questions, but one of those wheels is on display. One of those wheels is on display down in that booth, so come and pick it up. And just like to say thank you, and I'd be remiss, and I'd get my backside booted if I didn't say we are looking for new opportunities. So if anyone's got any, please track us down. Thank you.
And next up we have Johan Esterbeth from Contour Engineering.
Awesome, thanks for
Okay,
that.
no worries.
So first of all, guys, I'm not drunk, it's just the South African accent. So look, thank you for the opportunity. Obviously, you've heard from these previous guys as well, and I haven't realised how many of the companies that we deal with, the level of overlap. We deal in aerospace and defence and Yike Bike and Martin Jetpack, and so it seems to be a really small industry. But I thought, it wouldn't be right if we don't talk rugby first. Thinking about the All Blacks and their biggest competition, we have South Africa about 12 times the population. You think about somebody like the UK, they have about 14 times the population, Australia about 5 times, and they dominate the world rugby. And then I thought, the significance of the event, we did go out and win the America's Cup. And to be really part of that team and deliver that type of results at this stage really takes some doing. So I did some research. There's about 420,000 boats in New Zealand, recreational boats. And I went on to the American website for their manufacturing association, and they have about 18 million registered boats. So really, if we want to do justice to that, we need to cut that boat in half and still take away a little bit more. So it is a big industry over there. You think about Oracle versus Team New Zealand, what we've achieved is significant. You just look at the size of the populations. Boating is 42 times. The population is 68 times. So what we've done is really, significant on a world stage. And I think we've seen lots of these other companies demonstrating that as well, Olympic medals. So I thought I'll just talk to you a little bit about manufacturing. So we don't do probably the cool stuff some of these other guys do, where they, dynamic composites and composite this and that. But what we do, do really well is manufacturing. And I thought we'll just talk a little bit about this whole value chain. We were not the guys who came up with the idea for the cyclists on the boats. Let's just make that clear. But there's always, if you want to be successful, there's a lot of R&D that happens. There's lots of design effort that goes into it. There's a very, very, a big demand on getting your supply chain right. And then you get to manufacturing, and that's where we actually play our role. And then you go to testing and continuous improvement. And then ultimately you have a boat that is actually race ready. But if any of those in the value chain doesn't work, then obviously your boat might be race ready, but you're not going to win. So what we tend to find with our customers, we tend to end up with doing work for very highly innovative companies, very, very much on the cutting edge. And where they see the value in us is actually not just in the manufacturing. We do tend to get involved in that design phases, where people, come to us and say, can you manufacture this part? But the reality is, if you want to go into aerospace, if your stuff is not the lightest or the boat doesn't go around the course the fastest, we looked at what Oracle did. They started cutting weight out of the boat, and that's what we do. So we give you feedback into your designs. They call it DFM in the industry. We get involved very early on. We do the manufacturing. And a lot of our clients now actually ask us to move some of the quality upstream. So it's no use we ship your part for you and it arrives there and it is fundamentally not working. So look, our brand promise is a very simple one. It's on time, 0 defects. Obviously, if things go wrong, we fix it, and we do often get it wrong, but it's all about the relationships for us. Our brand promise is we'll deliver it on time, and there will be zero defects. Like I said, we do miss it every now and again, but that's what we aim for. So this is just a quick example. I know I'm running out of time here. Oh, you have 5 minutes extra for me. That's cool. But oh, just 1 minute. But anyway, this is just a few of the examples of what we do. People always get amazed if they look at the bottom, just the second one from the left there. It's a small hand and it's about this size. It is. We do the tricky stuff. If other people fail, they come to us, and that's when we help them. This is just us in the engineering news. Also, I think some other people do some work for Shotover as well. So they said, yeah, more than happy for you to use us for your article. Some of the other organizations or companies we do business with is up there as well. So just thought I'll share that. So just to wrap up quickly, we've been nominated as one of the fastest growing companies on the Deloitte Fast 50. We didn't win, but it was really good to just have that acknowledgement as well as of the effort of the whole team. And I've on purpose put these 2 team photos up there. It really is for us about team and partnership. We can, just do a part, but that's not what it's all about. So just to wrap up, there's our contact details. We also have some ebooks on the website, so you can download that. And that's just us on the cover of the engineering news. So feel free, let us know if you need a copy of that. We can scan it or send it through. So thank you for the opportunity, and maybe win the next one as well.
Thank you very much, Johan. Next up, our last speaker is Cam Walker from Jackson Electrical. Thanks, Cam.
Good afternoon, thank you for having me. So the title of my presentation is, wait, aren't we an electrical company? And that's very true. I'll tell you a little story about how a company from Onehunga in Auckland ends up machining dagger boards and rudders for America's Cup team. So the family I work for, Jackson Industries, that's a family name, Jackson. The company celebrated 40 years in business this year, which is pretty exciting. It was originally set up to supply electrical safety gear to Tasman Pulp and Paper, and that is still the core of what we do. I'll show you a little bit more about what we do in just a moment. So that's roughly 70% of our business these days. We do, however, have 5 other key business areas now. Precision machining is really what we're focusing on today, and in all we have 60 staff members, and we make roughly 20,000 products per year. So this is our day job. This is the core business, making lifeguards as we call them. So all these little yellow boxes is trade name as a lifeguard. So pretty much any building site that you go to in New Zealand will have some of our gear on it. It safely distributes the power around your building site. We also export heavily into Australia. And as a result of this business, we've actually got involved in CNC machining. So this is where we come into America's Cup work. This is a little bit of how the company has grown over the years. This is where Jim, my boss, started the business in his garage at home 40 years ago. And then this is the business, this is when I was born, 1986. So the business was already underway by then. And then this is what we are today, down here in 2017. So CNC machining is quite an unusual thing for an electrical company to do, right? But all of our boxes, the yellow boxes, they have to have holes cut in them to put electrical sockets on. So that is where we got into doing CNC machining. That was 20 years ago now, a little more than, 22 years ago. That's our first machine there. That photo is pretty old. And that machine still works in our factory. That still makes us probably more money than any other machine in our entire shop. It just cuts holes in lifeguard boxes, and that's all it does. Traditionally, we've just marketed through word of mouth. We have gotten involved in the jobbing work, like contract machining work in the industry. And that's recently, since I've been working for the business 5 years ago, that's really become more and more of a key business operation for us. We've been working with Team New Zealand specifically since 2000, so that was the first year the Cup was in New Zealand. And we've had growing involvement with them across all of their Cup campaigns, and this Cup this year has been by far the most involvement we've had with them today. So this year, our plant, we bought our 11th CNC machine. So the largest of that is 10 meters long and 4 meters wide and 2.5 meters tall. So you can see that we've got quite a large volume machining capability. We do a lot of work in the marine industry, making molds for boats, aerospace industry as well. I think Rocket Lab was mentioned earlier. They're probably, they are another company that we do a lot of work for. And on top of that, obviously, our internal work that we continue to do as well. So getting into the work that we did for Team New Zealand specifically, these are a few of the parts that you can focus on here. These are all the parts that we had involvements in. Specifically, all these things down here that actually get wet, we call those the appendages. So that's the dagger boards here that lift the boat out of the water, the rudders here that steer the boat, and then on the bottom of the rudder, just underneath the water, that's the rudder elevator, and that controls the pitch of the boat and basically stops it falling over on its face or on its bum. So this CUP campaign, we basically tried to take 3 years of work and condense it down into 2 years. We had a team of guys, Team New Zealand guys, on our site, and that was where all of the dagger boards, all of the rudders, all of the rudder elevators were built. They were working in conjunction with us, but that was a separate team. What we did was we did all the machining. So we did all the machining of the molds and also the machining of the parts. So by the end of the CUP, this is just sort of like what we did in numbers. We machined 10 dagger board shafts, 20 dagger board tips, 10 rudders and 20 rudder elevators. That's the large bulk of the work. We were also involved in the wing flap and wing spar tooling. As Chris's company, they actually produced the parts off those molds. We had a lot to do with fairings that make the boat more aerodynamic so it's faster out on the water, and also the bike pedestals. So over the 20 months that we were actively machining, we did over 250 individual machining projects. So that's basically one a day or something like that. So this is probably the exciting part. This is some photos, action shots from actually machining. This is a dagger board in our largest CNC machine here. Unfortunately, it has been photoshopped to try and remove some of the sensitive information. Now, this big, you can see the shape of the dagger board here. It's machined and it's sort of lying on its back, you might say. This part here is where the tip joins on. So we call this the shaft of the dagger board, this whole area through here. You can see in the background there the spindle. That's the part that actually comes along and machines this. And this entire surface through here is carbon fiber. This is solid carbon fiber layered up. 350 layers or thereabouts of carbon fiber make up one dagger board. It takes, your average dagger board costs in the hundreds of thousands of dollars, and it takes about 3 months to make from start to finish. So as I said, we made 10 of these things. Machining operations on these were roughly probably about 6 days per dagger board, spread across 2 operations. This here, this is a rudder elevator, as we talked about. So this is what stops the boat from falling on its face. So this is the same deal again. This is there's 2 parts in this photo. It might be a little confusing. You've got this part through here. It's solid carbon fiber again. This is the machine, the spindle here, the cutting tool here, coming along and surfacing this part so it's ready to go in the boat. The construction technique that we did with these is quite unusual in our industry, and normally you would machine a mold for both sides of the part, where in this process we actually machined only a mold for one side, so that's this black box you can see here. Onto that black box, the Team New Zealand guys laminated their layers of carbon fiber in this area, and then it comes back to us for machining of the top surface. So by going down this route, you have to be very accurate with your laminating, because you need to be sure that you've got enough material to actually machine away and create your final surface. But it affords you some benefits, one of which is that you only have to make 1 mold instead of 2, and that has a time and a cost saving. And it also has an increase in accuracy as well, because you're now direct machining that final surface that you want, so you can get it very, very accurate. This part here, this is a beam socket plug. This is another product that I think Chris's business was involved in. This, once again, is a big piece of carbon fiber on the machine. This is a slightly different topology of machine, this one here. These are the sockets that join the 2 halves of the boat together. The beams slot into the parts that they create. So now that the cup's over, what do we do? 250 jobs spread across 20 months is a fair whack of work to try and make up. So the first thing that we're doing first and foremost is catching up on a bunch of internal research and development projects that sort of got put to the sidelines. We're also extending our work into this sort of area with high-end carbon fibre work. And the next thing that's coming up is the next cup's only 4 years away now. And so we're already looking ahead to can we be buying new gear to get us ready for the next cup. Obviously, nothing has been signed yet, but we very, very much hope to be involved again next time. These are just a few photos of other jobs that we've been involved in recently. This one in the corner here is pretty unusual. That's a 6.5 metre tall fiberglass cow. So that's in one of our farming towns in rural Waikato and Morrinsville. And so we machined the moulds for this part once again from polystyrene, and that's now sitting proudly on site. This is another Waikato project, this one actually. This is not only is it a fully carbon fibre ultralight aircraft, it's also amphibious. It can land on water. And not only that, but its wings fold up and it goes inside of a trailer and you can take it away on holiday with you. So we've been involved in tooling for that project. It's very exciting, very cool. We also do a lot of work machining parts for more pleasure boats and that sort of carry on, and also race yachts. So this is a lead keel bulb that came to us recently. We machined 200 kilos of lead from that to reduce its weight and make the boat faster, basically. And yeah, there you go. So that's Jackson Electrical. Thank you.